that are going to be in that station, and we'll get into all these controls in the subsequent class. This will be after we've had training on these pumps from the vendor. For the most part, your pump stations, you're just getting brand new pumps put in there, and much better pumps and much better control. So again, it's instead of having to deal with pumps that, certain ones are stinkers and are not behaving well, you're now going to have good equipment that's operating well for you, so it's brand new. And you're going to have much better control for SCADA in that as well. You also have your waste-activated sludge pumps. And here we got 3 of them. And here you got tank drain and scum pumps. So you got your tank drain pumps in there as well. So this is basically all the stuff that you have in your north sludge pump station. The next thing I was going to get to is solids retention time. So what is the solids retention time? It's basically the average period of time that the sludge has remained in the system in days. Oftentimes people say it's what the sludge age is. Another way of saying it, similar, is the mean cell residence time. But we tend to work with solids retention time. There's different ways of calculating it. We have a very simplified way of calculating it here that I'll go through. And for the purposes of nitrification, the inventory will be only the portion of the mixed liquor volatile suspended solids that's under aeration. So it's only going to be the volatile suspended solids. Some plants will actually do the mixed liquor suspended solids, okay? And as long as they stay with the same way of doing it, it's they're being consistent, it'll work for them, okay? Bottom line is you get a number and you find the number that works best for your plant. Obviously, we've come up with an SRT for this plant, for the various the 3 different modes, each mode, to get the optimal treatment from that process. But you're going to have some latitude, because once you start operating that mode, you may find it might be a little bit higher or lower, but not horribly higher or lower, okay? Shouldn't be a big difference. The SRTA is specific to the plant's activated sludge process design. Typically, for a lot of the conventional processes, it could be 3 to 5 days. There's some plants that only have like a 1 or 2 day SRT. So for nutrient removal processes, your SRT is going to be higher. And in this region, we're looking at, it could be high around 8, 9, 10, even into the low teens. And for Upper Blackstone, it's going to be 8 to 10, depending on which process you're using. Solids retention time, temperature will affect the optimal solids retention time, because what does temperature affect as far as your process goes? The bugs, the activity of the bugs. So you got to take that into consideration that, hey, I've got this at the design SRT, but then you say, well, wait a minute, we've been having 90-degree weather for 2 weeks on end, going through a horrible heat wave, and the water's really, getting warm out there, So you have more activity. Or perhaps it's in the dead of winter and you're in a horrible cold snap where it's been like in the teens with a really wicked wind chill, and below 0 wind chill for like a week or so, and that's going to affect things as well. So nitrification, basically we're trying to get across, nitrification requires a longer SRTA, and it's limited at an SRTA of 1 day or less. So you can have nitrification even with a 1 day SRT. It's going to be significant? No, not enough to be worth your while. But it does happen. Okay, it's occurring. What you want to do is get it into the sweet zone where you're getting a lot of nitrification occurring. Okay, so that's why you want to have a longer SRTA. And as we said previously, we're going to be using the aerated mixed liquor volatile suspended solids pounds for our calculation. Your SRTA is going to vary with the process option. When you're operating the MLE or AO process, you have 3.7 million gallons per that whole train. It's going to be aerobic, okay? When you're operating the A²O process, you only got 3.1 million gallons of that whole train. That's going to be aerobic, as we saw from the previous slides where I showed you the aerobic zones, okay? So the A²O mode is the one that has the least amount of aerobic, because you're preceding it by an anaerobic and an anoxic zone. You're not using the swing zone as an aerobic zone. Okay, your SRTA, the definition is, in this case, because especially you're using the volatile, it's the volatile pounds in the aeration basin or your aerobic zone, divided by the suspended solids wasted a day, plus the suspended solids in pounds and your effluent that you
But
lose
the
out.
doses should be volatile in the denominator too,
Right, good point, yeah.
right? So it's VSS, VSS, VSS.
Yeah. Right, VSS, okay. And so you need the pounds formula, and as y'all remember, pounds is your milligrams per liter concentration times your flow or volume, depending on what type of pounds you're calculating, times 8.34 pounds per gallon, and that gives you your pounds of what you're looking for in your wastewater treatment process. That's the magic formula. The SRTA, so you're going to determine your MLVSS in your aeration basin or your aerobic zone. And let's say it's 3280 milligrams per liter is your MLVSS. Your average MLVSS, it's basically be your MLVSS 3280. In this case, we got 2 tanks, so 3.1 plus 0.69, because you got a full side. So like we're using tanks 3 and 4. This 5.65 is wrong. And then times 8.34. This part's correct. You will have 202,428 pounds under aeration of VSS. So then we have determine your TSS, in which case we should be saying VSS of the WAS. Let's say your WAS is 6,000 milligrams per liter concentration, and its flow is 0.40. Your pounds in the concentration, it would be WAS concentration in milligrams per liter, 6,000. Times the flow, in other words, how much you're wasting, times 8.34, we got 20,016 pounds of WAS. All right, now we want to know how much solids are lost in the effluent per day. Let's say we got 5 milligrams per liter going out, and your flow is 30 mgd. So you're going to have 5 times 30 times 8.34, 1251 pounds. So it's very insignificant usually what's going out in your clarifiers, unless you're having a serious chocolate milk episode out there that's going over the wires. All right, so then you're going to plug all these into the pounds formula. So your MLVSS 202,428 pounds, and then your pounds wasted 20,016, and then your pounds of solids going out in your effluent a day, and then divide it. In this case, I came up with 9.5 days. And here I have a slide showing what you guys are typically been doing out here historically, and your average is 9.33 days. Now, mind you, this is with the whole tank under aeration, okay? The volatile solids in there. But it's not like we're going to be too far off once we swing over. So getting into the range for the tank's not going to take long at all. Okay, once we get into the process, the results are down on the wall right out the lab there. Outside the lab, you can keep an eye on things. That's going to be kind of good. It'll be interesting to see when we start the plan up, watching the trend as we get into the new process. One thing I didn't mention, it's just because I don't have the information on it yet, but in your final settling tanks, you're going to have sludge blanket detectors. And since we're going to start getting into sludge settling characteristics, that's going to be the next thing here. That's going to be a very handy thing. Obviously, you're going to want to back check those with a sludge judge. And but this will now allow you to trend, because they'll be continuously monitoring the blanket in your final settling tanks. So sludge settling characteristics, this is again stuff that you should probably know from having studied for your license in the end. Bulking sludge is where you have poor settling characteristics, poor compaction. You'll have deeper blankets, and you'll be prone to washout. And causes. Typical causes usually filamentous growth, bacteria and fungi. Filaments, they're basically long and stringy, and so you end up having it's basically a less dense sludge. It's just stringy, there's a lot more water in it, so that, i.e., you're not going to get the compaction, and it's
sludge.
young sludge is one that can cause it too, because it won't settle as well. Young and restless, they'll say. But typically it's filamentous growth. What you want to do is stop the conditions that are causing the filamentous growth from occurring. Things that could cause it are loadings. I've had plants where basically they've had very high BOD loadings come in and just the plant just binges out and it's young sludge, and filaments also will start as well. Temperature, pH is a big one, and the degree of freshness of the wastewater coming in as well. If you get really old, stale wastewater coming in, or you get a lot of septic loads coming in, smaller plants will be affected more so than bigger plants that can assimilate them. The other thing that will cause it is low DO, inadequate wasting, an inadequate return rate, and unbalanced wastewater distribution across the final settling tanks. These can also cause bulking. You can have what's referred to as hydraulic bulking, and that's just the blanket's not settling because you're overloading the clarifier and you're exceeding its ability to allow the sludge to settle. Remedies, if sometimes, again, with a huge plant like this, a small contributor is not necessarily going to be, it's the tail wagging a dog and it's going to really throw the plant. It's usually a lot of times in smaller plants that a certain industry could like throw a plant because all of a sudden they start dumping on you. May cause a certain filamentous organisms to start growing, and so you'll have to do microscopic analysis and hope to identify what's causing the problem. Oftentimes you may enlist the help of experts that do this all the time. This guy out in California, Jenkins, people send their sludge samples and scum samples out to his people, and they'll do staining and microscopic analysis, and they will actually identify the specific problem, organism that's causing the trouble, and even come up with remedies from their database, and also what could be causing it. They'll tell you, here's what we think typically causes this to show up, and here's typical remedies that have worked across the country. So they got a huge database. That's a resource that we've used before. Again, your proper remedies available short term can be changing the RAS rate, adding settling aids, chlorinating the RAS. Very carefully and judiciously chlorinating RAS, because you can also wipe out your plant. And I've seen that happen too. Long term would be basically control your mixed liquor suspended solids pH, control any primary effluent septicity, adding nutrients. Some plants have issues with nutrient deficiencies. Again, it's usually typically smaller plants or plants that get swayed greatly because they've got a significant portion of their influent is industrial. And changing your aeration rates. Again, if you have a plant that's for the most part getting domestic wastewater coming in from a wide, varied community, it's pretty homogeneous and pretty well balanced out of a diet for the plant. It's oftentimes when a plant is either swung by high infiltration or industrial that will throw the plant, or if all of a sudden, like for a smaller plant, if you're taking a lot of septogen, and it just starts throwing the plant as well. Oftentimes you'll have plants that have seasonal variations, like maybe they might have a food processing or canning plant online, and seasonally they could get some wide fluctuations in their loadings too that'll throw the plant. So this is stuff that not only you would think for your plant if I'm having problems, but just in general if you're being asked these types of questions on your exam. Speaking of bulking sludge, have you guys had issues with this, and what have you done out here? Comments?
Well, we've chlorinated in the past.
Okay.
We've had, yeah.
Polymer. Okay. Okay, so you've dealt with it before, you've seen it. Yeah.
Every year.
No, again, as we said, with the new nutrient removal processes here, you will have a better settling sludge, so you may be less susceptible to having this problem occurring, I would hope. That's one of the benefits of running a nutrient removal process, is getting a much better settling sludge. The selectors just encourage it because of the ratio, the food microorganism ratio in them. Okay. So rising sludge, now this is another one. This should not be a problem at Upper Blackstone. Rising sludges have good settling characteristics, but they tend to rise to the surface after a short time in clumps or mats. So initially, they initially would settle well, But then all of a sudden they tend to rise up to the surface after a short time. And where would you see this visually in one of the tests that would be performed? What test where you could tell?
So,
Exactly. And you see how it'll settle really great, then all of a sudden it pops up on you too premature. Yeah. And what happens, DO is consumed in 10 to 15 minutes, and your gas production is in 30 to 60 minutes. So proper operation of the aeration system is going to reduce the nitrate level sufficiently and provide sufficient DO in the MLSs to prevent rising sludge if the RAS rate's correct. Also, if you're operating, you're operating where you're getting good internal recycle and you're denitrifying it, very well in your anoxic zone as well, because you can have plants that are denitrifying their clarifiers, and when you're denitrifying in your clarifiers, besides the rising sludge, what are you seeing a lot of? You ever observed your clarifier? You see a lot of bubbles coming up off of it, and that's what's buoying up the sludge. So have you guys had any problems with this rising sludge?
I've seen it one time, that was because a clarifier collecting system was shut down. When we started it up, boy, it really released some of that.
And that's the other thing that can cause it too, is you can have rising sludge from totally it's still biological, but it's a mechanical problem that's caused it, and what it is your sludge collection wasn't adequate enough, and you had enough areas in the clarifier that were not being collected from properly. So when you do have rising sludge, one of the first things you want to look at is, am I properly removing my sludge from the bottom, or do I have a strip in there that's like a dead strip and it's popping up? And that's important too, because you have the draft tubes out there, and when we start the plant up, we're going to be operating all those tubes will be pulling, and we're going to try to pull uniformly, okay? And we want to make sure that they're pulling uniformly, because we'll be monitoring the blankets. We want to make sure that we're pulling the sludge efficiently. We're not pulling really too thick where you're letting it sit too long, or you just return it ridiculously fast, okay? And again, that's why we're looking at a return rate initially of 69% of the average daily flow of your primary effluent. Then you got foam forming sludge, and that's usually, and again, SVI is something that's often, it's very plant specific, but usually you have an SVI between 100 and 150, and it'll produce a turbid effluent after settling. It produces a very stable scum on the aeration tanks that cannot be broken up with a water spray. And it results from an overgrowth of actinomycetes. It's a very small, highly branched filaments, fungi. Actinomycetes produce a lipid, fat byproduct. The reduction of sludge detention time in the final settling tanks is the cure, not chemical treatment.
What is that, Nocardia fungi? What's prevalent with that problem?
Nocardia is one that's associated with the forming sludge.
Is that caused though by the fat, the grease?
Yeah,
Yeah, it is.
that's what it is. Yeah, the greasy stuff, because it's basically breaking down, and you're getting the lipid byproducts from the actinomycetes forming it. And again, this could be there's variations on this. You can send these samples in to somebody like Jenkins, and they can find out specifically what's causing the problem. We tend to want to group things by here's what it generally is, but it's not unusual that you could have a plant that's got something that's totally oddball to itself, that maybe only another plant in another state's had it, or it just depends what the heck's coming in with your influent. You get your septage loads coming in can throw plants again, and oftentimes with a plant, it could be very short-lived. You could have something really squirrely happening for a few days, and it just works its way through the system. Other times it'll take a foothold. I've actually started up plants by using seed sludge from another plant. Sometimes it works, sometimes it doesn't, where I've had trouble. In general, if I've got a new plant to start up, if I can just do it with the mixed liquor, forming the mixed liquor from the influent coming in, and let it gradually build on what's normally being fed to it from the community, I'd rather go that route, because that's what it's normally going to be fed off of anyways. But I have started a plant one time where we brought in sludge from an adjacent plant, and it was more headache than it was worth. We actually inherited their foam problem. But then I've done another plant too, where it was a plant not far, it was right nearby, and very similar influent characteristics. We trucked the sludge over, no problem starting it up. So it's just something to think about, that when you have these problems, your population's changing a little bit, and something's caused it to change. So you gotta stop and think, what's caused that change? Your biggest effector of your plant is your influent, okay? And then, of course, it's what you're doing internally in your plant. So long as you're consistent and, providing the, neutral pH, in this case, this plant, we'd like to see around a 7.2, actually. Good, adequate alkalinity for your process, keep an eye on your alkalinity, and you keep an eye on your DO. You're doing what you can do for the home base, okay? And then you just gotta deal with what's coming in with your influent. And again, you've got options there too, because if you get a high storm event, and you're not going to overload the plant hydraulically. You now have your option, and you will be doing it too, of course. Is you're going to take what the plant's designed to take flow-wise and divert excess through wet weather discharge. So this is all trying to keep things, tighten up how the package is being run, so to say. Now when you get into return sludge control, because I went through basically the typical things that you'd see the issues with your clarifiers. If your RAS rate's too low, you can have an insufficient number of microorganisms available to treat your BOD and nitrogen loading from the primary clarifiers, or primary settling tanks. Long detention times lead to anaerobic activity leading to gasification and rising sludge. Deep sludge blanket may allow solids to be discharged over the weirs and into the final outflow. If the RAS rate's too high, it'll increase the hydraulic loading to the secondary clarifiers, or your final settling tanks in your case, and reduces the detention time needed for proper settling. Your hydraulic loading is just too high. RAS concentration will decrease, requiring more power to return the same number of microorganisms. So here's an example given. Let's say just taking the number. Let's say you're doing 3,000 gallons a minute, and you get 6,000 milligrams per liter as your concentration, times 8.34. Well, that's the same thing as doing 6,000 gallons a minute times 3,000 milligram per liter concentration. But if you look at the two, this is equal, but which is more efficient energy-wise as far as returning? The first one, the higher concentration, okay? And that's probably, the 6,000, that's obviously a much more normal what you would see for your return concentration. If you're returning a concentration of 3,000, that's almost like throwing mixed liquor, literally. Because your mixed liquor concentration here, we're shooting it around 4,100. All right. So when you're returning like that, a lot of times when you're returning too fast, what happens? What do they call the situation if you're returning too fast with a sludge? Coning, or have you ever heard that? Rat holing, coning. What happens is you're now pulling water with your sludge, and you're diluting your sludge. So you need to just back off. And again, where would you check, like on your draft tubes? You check right up at the ports. You can take individual samples and do a sludge spin down, so you can make sure your ports are set properly. Okay. And usually once you have them set for your flow regime, and this will be when the clarifiers get commissioned and that. Once they're set, you just only have to go back and routinely check them when you're suspecting a problem. And you can visually look and tell if you're having, after a while you can tell by looking, if they're returning good, if they're plugged or not. And as you said, fortunately at your plant, you've not had issues with those plugging. I've been at some plants where they go out and they've been having serious issues with these plugged. They're small. You've got pretty good size draft tubes out there. So, okay. I'm going to go through two different ways of determining and returning activated sludge rates. And again, this is all part of your bag of tricks because we want to be consistent with our return rate because that's what's coming up into your, that's your establishing your food to microorganism ratio up in the A zone, your A selector, okay? So you want to be consistent with what you're returning up there to meet your influent flow, all right? But there's going to be times where I know you can use this as a tool too to help maintain the proper function of your clarifier as well. Make sure you're keeping your blankets down in. So I know that this is something that you often have latitude with, but not a lot. We want to try to keep this in the design parameters that have been established for these modes that we're going into, okay? So to maintain a desired mixed liquor suspended solids for a given food to microorganism ratio, and that method requires that the RAS rate be calculated based on the concentration of the settled sludge in the final settling tanks. That's one way of doing it. The other one is to maintain a minimum sludge blanket in the final settling tank so there's no buildup in excess of the blanket needed for achieving efficient return rates. Some plants will actually just do, they can do a return rate that is constant regardless of the flow to the plant. In which case your sludge blankets are gonna, they will fluctuate through the day. And in the case of this plant, we want it to be a percentage of your primary effluent flow. You know, again, like I said, we're shooting for 69% of the average daily flow of your primary effluent. Okay?
Now, is that something you're gonna program in the SCADA?
Exactly, and that's where Susan, she's gonna get into this with you guys as to the control of that, okay? And this is how most plants I've worked with, especially larger plants, they have your return rate as a percentage of your primary effluent flow. But I just want to show you these two ways because, you know, this is stuff that you need to be aware of for, you know, sitting for your license and that, you know. So here's one way, method A. You're going to do this based on a mass balance of the activated sludge in the system. And if you remember back, the RSSS is the return sludge. This is the concentration of sludge that settled in your clarifier. That was from an earlier slide. The formula is basically QR over QS. And if you want, you can get rid of those two equal signs in the middle. You should kind of put one right there. But it's basically QR over QS will equal MLSS over RSS minus MLSS. And again, like I said, RS